1 minute. Okay, time up. Let's see how we did. So the first thing, the heating system of a car windscreen is made up of 10 elements in series, each resistance 2, battery 12. What's the total resistance? Okay, so if it's in series, what formula do we use? Yeah, R1 plus R2 plus da 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 da, R10. Yeah, yeah, so it's 2 plus 2 plus da 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 2, which is 20 ohms. Okay? Next, what is the power? So, power equals IV, but we don't have the I, but we can use the triangle VIR. So the I can be replaced with V over R. The V squared is, yeah, it's 12 squared, so 144 over 20. Is that 7.2?
Yes.
7.2 watts. Okay. And then determine the power if they were in parallel. Okay. So, it's 1 over R equals 1 over 2 plus 1 over 2 plus da 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 da. 1 over 2. That's just 5, yeah. So that means R is 0.2 ohms, right? So the power equals V squared over R equals 144 over 0.2. And what's that? 700 and... what is it? 720 watts. Yeah. Okay. That was good for 5 marks, wasn't it? Yeah?
I missed the 1 over 5. I only get 5 over.
Oh, okay.
Formula. No, next.
Hang on, sorry. Where's the... what's next? 6. Okay. Right, so this is 3 marks, 3 minutes, go. Sorry. Finished already, Ben?
What kind of weight? Earthquake weight.
Do the next part. Have a guess and do the next part. 1 minute left. Finished? Please. 30 seconds. Yep. Right. So, first part, did you get it, Ben? Or Gow, did you get the first part? What wave? Oh. Transverse, very good. So you're on the ground and the wave is moving like this on the earth. So this is, transverse S wave, transverse wave. Remember you have the two types?
Other type.
Longitudinal. Yeah. Right. Well, that's why you can use, what did you say this one was called for short? This one is an S wave. And the other one is a P wave. Now this one's an S wave. Yeah, and the other one is a P wave.
So what is P wave?
Oh, it's hard. You can't draw it because it's vibrating out like this. You can't. Like I draw it like this. You can't draw it. Right. Next, what is the wavelength? So you have V equals F lambda. So lambda equals V over F, which equals 4,000 over 5. Which is 800 meters. Yep.
I lose the M.
Oh, you lose 1 mark if you do that.
Unit
You lose 1 mark.
is total or only this? I mean,
Total.
total.
Yeah.
So if I want many questions lose the units, so only one.
I think yes. So it's okay.
It's okay.
Yeah, but what if you were on like 69 and you
No.
needed 70?
No.
Alright. Okay, next question. 3 marks, 3 minutes, go.
It's 3 marks.
Yeah, 3 minutes. Yeah. Okay, I don't think it'll take you 3 minutes. What notes are you checking? You don't need to check notes, do you?
What is V?
Gamma.
0.
Right, let's have a look at this. You haven't finished, Gal? No, sorry, go ahead. You still have lots of time. You haven't finished,
It's a
Gal?
big it's natural nucleus.
Big N is what?
It's natural nucleus.
Yeah?
Natural.
You know this.
I just thought that.
You know this.
was-
Don't don't make Lorraine angry. Lorraine will be very angry at you, won't she?
Oh,
1 minute left. You have it?
If I just balance the proton and electron and the mass over the mass, it's impossible.
Impossible? How is impossible? Right, look. What number goes here?
Zero,
No, here.
the one,
No.
what? Minus
Minus 1.
what?
And what number goes here?
Zero.
0. Gal, are you looking?
Okay.
Because this is remember, this is beta. So what goes here?
14.
And here?
7.
Done. Did you get this, Gal? Did you get this, Ben?
No.
What went wrong?
Minus one.
You were 1.
I write zero.
Ah, no. Did you get this, Khalifa?
14 and 7.
Okay, fine, good. That should get you some marks. Maybe we need to watch the video again. This is, remember beta?
I know.
Yeah.
I forgot.
Okay, fine. Well, you can check it later, beta. Okay. Next now, let's see, what's next? What is next? 3 marks, 3 minutes, go! One minute. Okay, let's have a look. The Broglie wavelength of a beam of protons, is 7 times 10 to the minus 14. So the wavelength is 7 times 10 to the minus 14 meters. What is the speed of the protons? So we have to use the Broglie's formula that says lambda is h over mv. Therefore, v is h over m lambda. So v equals, now let me open up the calculator. I've got a calculator right here. Now I keep needing to write this down somewhere. Because I have all the constants on my calculator, but I just don't remember their codes. I'll show you now what I mean. Anyways, once it opens here. How's your lunch? Good. Did you have breakfast? Did you have cigarettes? No breakfast, cigarettes and fried chicken. Right. Shift 7. Now which number is H? Oh, 31? Nope. 32? No. Does anyone have this calculator? 33? Maybe 34, yeah. 35? Oh. I'll find it. Gee.
18.
I'll find it.
The edge is the 6.6.
Yeah, I know, but
It just
no. Fine, okay. No. Okay, who has Google on their phone? Can you type in Casio 991 lid?
991, I believe.
Yeah. Now, have you got pictures of the Casio lid? What kind is this then?
You show me pictures if you want to buy.
Oh, I need the lid. Let me have a look. See, I want the lid because I want the list of constants. Oh, here's a picture. Can I zoom in? Ah, beautiful. Right. Can someone just write these down for me? Number 1 is the mass of the proton. Number 2 is the mass of the neutron. Number 3 is the mass of an electron. Number 6 is H. What else do I need to know? And number 23 is E. And number 39 is G. And number 27 is OR. And number 25 is K. Oh, and then number 40 is U. There you go. So, someone write them down for me?
you are right down. Alright.
Yeah, but I'm going to delete.
I need to let it go. Number 1 is mass of proton.
Please.
Neutrons.
You guys don't help me.
You already done it.
You wrote them all these down?
Yeah.
You got them all?
Yes.
Okay, there's at least one student I can count on. Thank you. Okay, so what number did I say
6.
was H?
6.
H was 6.
Okay, so let's just put this in precisely. Okay, great. What is mass of proton?
MP. 1.
Times 7 times 10 power minus 14. So we get the exact perfect answer. Perfect answer is this. If you want to write that down. Now your answer doesn't have to be exactly this, but this is the perfect answer. It's the beautiful answer. Continue? Yeah? Okay. Next now, what happens if the speed is half? What happens to the wavelength? So, what happens to the wavelength? Very good, Ben. If this speed is multiplied by half, then in total it's like you multiplied by 2. So you're right, Ben, it's doubled. Very good. Okay, and then lastly, what wave-like process will occur if particles like these protons meet objects with dimensions similar to the particle wavelength? Now, we didn't really talk about this in class yesterday, so I don't know if anyone has an idea.
Can you explain what's the question?
Yeah, I'll explain the question. So they want to know. No, look, no, you don't have anything. You need to listen. So, here is your photon, right? And they said the photon, remember we said this yesterday. Eat the chicken for a moment. We said this yesterday. The photon will behave like a wave if we don't look at it. Remember we said this? So imagine now the photon has become a wave. What will this wave do if it passes through something which is about the same size as the photon? What was it, 10 to the minus 14 or something? Yeah. So what do we call that in the chapter when we studied waves? Do you remember this when we studied waves? Something happens here. No, don't look. What happens here to the wave?
Stop.
No, it doesn't stop. Do you remember it does this?
The same.
No, it does this. Do you not remember?
Planets.
What's it called?
Planets.
Ooh, close, but not quite.
With the fading.
Huh?
With the fading.
No. It's not quite that word. It is that lesson though. Uh-oh. No. Have you got your wave notes? Waves from semester 1.
I didn't.
No, this one. The Fraser one.
It's before that. You didn't write. It was the lesson. Hey, it was the lesson we did called reflection, refraction, diffraction.
Diffraction.
Yes.
Diffraction.
Yes. Diffraction.
Oh. What's the Oh, maybe.
You guys
I
drive
know.
me nuts.
I know. Combined.
Interference. There was this lesson. You need to check your notes. Reflection, diffraction, refraction.
Yeah. Yeah, I know.
Do you? So it's called diffraction.
Oh, you like
No, that one's called refraction.
what is
That's diffraction. Do you have it in your notes? Go. Show me.
I know the line. I don't know the weight. Yeah, the same.
Oh, yeah, you didn't draw it. You didn't write it down.
Maybe only me.
Maybe I missed this.
Did you write it down? Where's your notes?
Oh. Which one?
Waves.
It's okay. I will check.
No, maybe Summer has footnotes.
No, maybe I have another book. It's
Okay.
also this book. Yeah, it's maths. Okay. It's a new book.
You see, when you miss class and you don't write things down, this is the problem. So this is called diffraction.
Diffraction.
With a D. Yes, D. Diffraction, yes. So, that's what it's called. That's the answer. The answer is just diffraction. 1 mark. Alright.
That's third question. Oh, that's third. P-I-F-R-A-T-I-O-N.
Yeah.
C-T-I.
Nearly, yes.
Yes.
Okay. Right. 4 marks, 4 minutes, go. Yeah.
Why one English word have 5 definitions?
What's the word?
So, descriptor.
Huh?
Descriptor. It comes for 3.
What's the word?
One is and one is.
Where's the word?
Yeah. Is.
Where, I can see. No, point. Where's I don't see it. Where? I can't see anything. Oh, there. Discipline.
Yeah.
Discipline.
One is this and another one. I think I got this one
Principles.
and this enrolled. Enrolled. I know this means, but it's just only one and the others both.
These words are old common words, so they will have many meanings.
All the common ones.
They're old words that are used a lot. In English, when you have a word that is old and used a lot, it has many meanings.
Sorry, I have these stuff.
Reflection, diffraction, refraction.
I don't know.
Good job, Dan.
I forgot.
One minute.
Do I have formula? Oh, we have formula.
You have a formula book here?
U6.
Huh?
U6.
Useless? Okay, time up. Let's look. Two large metal plates are separated by a centimetre and 1,000 volts is placed across them. Determine the electric field strength between the plates. Right, who remembers the formula here for E? Anyone remember? V over D. That's 1,000 over 0.01. Yes? Which is 10 power 5 newtons per coulomb.
It's,
Yes?
it's 0.0.
Yeah. Yep. What's wrong?
1,000, I think.
Oh,
It's 3 0.
here. 3 zeros.
0.00.
No, it's 1 centimetre.
Yeah, 1 meter. Oh, fuck. Oh, what?
Continue.
Yes.
Determine the magnitude of the force on an electron placed between the plates. So, you remember the formula F equals QE? Yeah. That's 10 to the 5 times the charge of an electron. Now, Khalifa, no, give me the constant number on the calculator. What number is E? No, the list I gave you earlier.
E is 22.
1.6 times 10 to the minus 14 is the answer.
Why is not minus?
No, the minus is only for the direction, and they don't care about the direction. They only care about the, see this word, the magnitude, yeah.
But
What did I say this was? 1.6, was it?
Yeah, 0.6 times 10 to the 14.
What, Ben?
where the formula
Yes.
No, Ben. Ben, it should be up here.
Oh, I see this. Oh, yes.
Continue. Continue.
Yes.
Sketch the diagram showing the electric field straight where the upper plate is the positive. So do you remember the picture here? Positive,
Yes.
negative, and then the field lines go like this. And don't forget, at the end, you need to bend them a little bit. Like that.
So,
Nice.
Where is the upper plate?
Hmm?
draw this.
The upper plate is the line on top.
But it's magnet.
Huh?
Magnet. Something.
What?
It's electric.
Yeah. Electric field, yeah.
I remember it's the magnet.
Ah.
Magnet.
Well,
Sorry.
Okay.
Mistake.
Okay. 4 marks, 4 minutes, go.
Oh, is C. Oh, what's the
Poor Summer. You make so much trouble for yourself. Why can't you be like Ben? Ben is never trouble.
No. What was
Huh? You're never trouble.
why?
Why? You're a good student.
Oh.
Sometimes Ben is a little trouble though.
What's the
The
time?
time? 12:48. Why?
If I go,
Yeah?
I missed one class.
Yeah.
Just one.
Yes.
1 hour.
Yes. Okay.
I will see the video.
Please.
Okay. And you can leave some message.
I will leave some message for you.
No. What is energy? What is the charge? I think Q C equals
10 seconds.
it doesn't
Now be good.
doesn't has the foundation formula. What is the charge store?
Okay, let's look. A capacitor of charge 40 or of capacitance 47 microfarads is charged from a 9-volt power supply. What is the charge stored? Right, so that's Q equals CV, right? So what's that, please?
47.
times 10 to minus 7.
What is it?
47 times 10 minus 7 times 9
Yeah.
comes to 4.23.
Ah, yeah.
4.23 times 10 to minus 5.
Thank you. What is the energy? So do you remember the formula? Energy equals a half CV squared. So that's a half times 47 times 10 to the minus 6 times 81. What's that?
1.9 times 10 minus 3 joule.
If the determine the capacitance if you want double the energy. Okay? So look, this is easy. If you want this to be twice as big, then this must be twice as big. So the answer is simply 2 times this, which is 94. The answer is 94 microfarads. Hmm?
Yes.
Yeah? Yeah?
What a CV.
Huh?
CV.
You've got a CV.
Oh.
You forgot CV. Trouble.
The following book.
No, look here. Okay. So we'll leave one message in each video for Summer. So,
Yes.
wait, I'm leaving a message for Summer. Right, so there's Summer. Summer is a little taller than me, isn't he? There's me. Okay. Here's a cappuccino. And a little arrow here. Okay. And the question for Summer is, what does this mean? Yeah? Yeah? So like here, what? And then
Equals NA.
yeah. What does it mean?